Industrial gases such as nitrogen can cause serious injury or death if not properly handled. You should only handle industrial gases or operate industrial gas equipment if you are a trained professional. Messer Americas makes no warranty or representation as to the suitability of the information provided in this program for any particular purpose. You, the viewer, rely on this information at your sole discretion and risk. The information provided in this program may not apply to all situations and is not intended to replace an industrial gases safety training program. You should always follow your employer's safety policies and procedures. This program instructs the viewer to call or contact Messer under certain circumstances. If you work with industrial gases and equipment that is not supplied by Messer, it is important that you contact your industrial gases supplier if you have an emergency or require support. In this program, we'll take a look at the safety guidelines for working with nitrogen in both liquid and gaseous forms. We'll cover the basic properties and behavior of nitrogen, how it's piped and stored for use, and we'll also examine the safety concerns associated with oxygen deficiency and low-temperature burns. When used in large amounts, nitrogen is always stored as a liquid under low pressure. This is more practical than shipping small cylinders of compressed gas because liquefied nitrogen takes up a lot less space. 1 gallon of liquefied nitrogen will expand to over 90 cubic feet as a gas. At industrial sites, liquefied nitrogen is always stored in vacuum-jacketed tanks. These tanks are basically like big thermos bottles, super-insulated containers for storing low-temperature liquids. There are several important factors to keep in mind concerning the storage tanks and associated piping systems. There is one main liquid isolation valve located at the bottom of the tank. This valve can be used to isolate the supply of liquid from the tank to the vaporizers and stop the flow of nitrogen in case of a leak or other emergency. Ice buildup on the tank piping is normal, but it should never be allowed to build up to the point that safety relief valves are blocked. Some minor venting is normal, but excessive venting is not. Contact Messer at the number provided on the tank if it's suspected that any problems exist with the tank or associated piping. Always keep the tank area clear of material, cars, and other vehicles. Backing in a liquefied gas delivery tanker takes a lot of room, so be sure to maintain a wide, clear path at all times from the road to the tank. Only a trained industrial gases delivery person should perform unloading. Nitrogen piping systems are just as important as the storage tank, so be sure to protect them from potential damage. Keep forklifts, trucks, and other heavy equipment well away from all system components containing nitrogen, liquid, or gas. Liquefied nitrogen piping can be made from a number of materials, including stainless steel, brass, or Type K copper. But all brazed joints must use cadmium-free solder that's at least 56% silver. For both safety and efficiency, pipes carrying liquefied nitrogen must be insulated. Typically, a 2-inch diameter copper pipe will require a 3-inch thickness of polyfoam insulation. Another option is vacuum-jacketed stainless steel. But pipes carrying nitrogen gas don't need to be insulated because they're not that cold. If you need to replace or add piping carrying liquefied nitrogen, be sure a qualified engineer reviews the design, the choice of materials, and the pressure ratings for all system components. And piping carrying liquefied nitrogen must be labeled indicating its content according to labeling standards specified for your site. It's important that liquefied nitrogen never be trapped in a container or a section of pipe without safety relief devices installed. These devices must always be present to vent gas when pressure builds up. Here's why. Imagine boiling water in a pot with the lid clamped on. What would happen? The water boils, steam pressure builds up, and before long, you've got a very hazardous situation. If liquefied nitrogen is trapped in a tank or pipe with no venting, you've got the same situation. Even though it's very cold, liquefied nitrogen is actually boiling as it evaporates. This could build up tremendous pressure, enough to cause piping to rupture. Safety relief devices must be installed in all piping and storage systems, anywhere that liquefied nitrogen may become trapped. Liquefied nitrogen is very cold. In a tank and piping system, liquefied nitrogen can be as cold as 320 degrees below zero Fahrenheit. Never touch any parts of the piping system with unprotected skin. Your skin would freeze right to the metal and tear if you tried to pull loose. Gaseous nitrogen is odorless and colorless. The vapor you sometimes see is misleading. That's just water vapor condensing in the surrounding air. Once it has reached normal air temperature, nitrogen gas is completely invisible. The temperature of nitrogen gas can vary a lot depending on how it's created or vaporized. It can be anywhere from 320 degrees below zero up to ambient temperature or beyond. And remember, nitrogen gas does not necessarily need to be visible to be a hazard. Let's talk about the risk of low-temperature burns. If your skin comes into contact with liquid nitrogen, you can suffer frostbite. Contact of even a few seconds can be very painful. But even without the pain, this kind of injury can be recognized by the yellow, waxy appearance of the frostbitten tissue. If you get a low-temperature burn, don't rub the frozen area, and don't try to warm it with dry heat. Instead, put the affected area under lukewarm, never hot, water, and remove any restrictive clothing. Because of the risk of low-temperature burns from liquid nitrogen, you should always wear protective clothing. This should include long-sleeved shirt and pants of 100% cotton, eye and face protection, safety-toed boots, and loose-fitting insulated gloves. If you're working with liquid nitrogen, realize that if you put anything into the liquid will always boil and splash. This is normal and unavoidable, and it's the main reason for wearing protective clothing for this kind of work. Nitrogen does carry the risk of asphyxiation. The gas itself is not toxic, but if enough nitrogen builds up in an enclosed space, say a manhole or other poorly ventilated area, it can displace enough oxygen to make the air unsafe. Look at it this way. Air is normally 21% oxygen. If that number falls below 19.5%, the air is considered oxygen deficient, and if you're breathing it, you'll start to feel physical symptoms. As the percentage of oxygen drops, the symptoms get worse. And if you walk into an area where the air is less than 12% oxygen, you can black out after taking just 1 or 2 breaths. To avoid an asphyxiation risk with nitrogen, you should monitor the oxygen level in the air. If the oxygen level drops below 19.5%, the air is unsafe. You should leave the area immediately and do not allow others to enter the area. When liquid nitrogen first evaporates, the cold nitrogen vapor is heavier than air and will sink to the floor and settle in low-lying areas. But nitrogen gas is actually slightly lighter than air, so as the vapor warms up and finally reaches ambient temperature, it tends to rise and collect at the highest point. Keep in mind that fans, machinery, and even people moving around have an effect on the air currents in a particular space. This means that where you work, nitrogen gas may in fact not rise to the highest point in the room. It can be anywhere depending on the ventilation and general movement of air in the area. It's critical to identify the areas presenting the greatest risk of oxygen deficiency from nitrogen gas. Entryways to poorly ventilated areas where nitrogen gas could collect should be marked with warning signs. Ventilation systems must be in operation and maintained in good working order. All employees who work in the area should be trained to recognize the hazards of liquid and gaseous nitrogen and to properly respond if there is an alarm or other emergency. All affected employees should also be familiar with the safety data sheet on nitrogen. Safety data sheets are available from Messer, and they provide important safety information, including hazards of the product, first aid, and accidental release measures, personal protective equipment, as well as proper procedures for handling and storage. Let's review the key points on nitrogen. Liquid nitrogen will always boil and splash. If liquid nitrogen comes in contact with warm objects or surfaces, boiling and splashing will be more severe. Make sure that proper protective equipment is worn when working around liquid nitrogen. When cold, nitrogen gas will lie along the floor and settle into low-lying areas. But the gas is naturally a bit lighter than air, so as it warms up, it rises to the highest point in a room. Nitrogen does present a risk of asphyxiation. The gas itself is not toxic, but if too much of it builds up in an enclosed space, it displaces the oxygen, making the air unsafe. Facilities that use nitrogen in any form should always be equipped with exhaust ventilation systems and oxygen monitors. If you suspect unsafe nitrogen buildup in a particular area, do not enter. Notify the appropriate safety personnel and keep other people away. Industrial gases, such as nitrogen, play a critical role in manufacturing, food processing, healthcare, and literally thousands of other applications. Understanding their properties and behaviors, as well as employing best practice handling procedures, ensures a safer workplace whenever they are present. For more information on industrial gases, such as nitrogen, or to obtain safety data sheets for any industrial gases, visit our website at www.messer-us.com. Thanks for watching, and have a safe day.